I'm Dr. Jagadha, Associate Professor in the Department of Mathematics. Today, we are going to discuss mainly about discrete and continuous probability distribution. This lecture includes discrete probability distribution, continuous probability distribution, and problems on discrete probability distribution as well as continuous probability distribution. So we can see here discrete probability distribution, otherwise it is called as probability mass function. Here probability density function or continuous function. If probability of xi, that means for all I is going to take the value from 1 onwards to n. Then that probability of x1, x2 up to probability of xn, it's nothing but 0 or positive. So the probability is always positive. That is the first condition. The second condition is the sum of the probability which is always equal to 1. These two conditions are satisfied, then we will call it as discrete probability distribution or probability mass function. Here coming to this continuous distribution, f of x is greater than or equal to 0. Here also the probability is positive, and integral minus infinity to infinity f of x equal to 1. That is the total probability is equal to 1. Here the integration is playing a role in continuous probability distribution, whereas summation is playing a role in the discrete probability distribution. This is the difference between the formulas. Students should keep in their memory space. Integration related to continuous distribution, summation it is related to discrete probability distribution. Strongly they have to understand. Next, mean of the discrete probability distribution. This is mean. It is denoted by mu. This E of x, it's nothing but expectation of x. So summation I equal to 1 to n pi xi. Here, whereas coming to continuous distribution, mean of your distribution that is continuous is integral minus infinity to infinity x f of x dx. We have to be very careful. Next, variance. Sigma square equal to E of x square minus mu square, and variance of a continuous distribution is integral minus infinity to infinity x square f of x dx minus mu square. So if you are noticing that this it's divided into discrete and continuous. Completely integration. Here, the integration is playing a role. Here, the summation is playing a role. That part to be very, very clear. And cumulative distribution. This is the formula. Summation I equal to 1 to x, probability of xi, continuous, probability of x less than or equal to x. Here minus infinity to x, f of x dx. Dx to be written there, f of x dx. So, from this, what are the important formulas are listed under discrete and continuous. This should be very, very clear picture about the formulas. Now, we will do one problem under discrete distribution. Here we are noticing one die. Yeah, two dies are there. Dies, we know it, 6 faces. Here, if you're noticing here 5, here 4. So 6 phases, each phase 1, 2, 3, 4, 5, 6. These dots will be there. Now, according to our problem, we have taken 2 dice. Die, singular, dice, plural. A random variable capital X, which is defined as sum, addition. Numbers on the faces when 2 dice are thrown. So we have our 2 dice, we are going to throw it. It's not giving a gap, 1 die throwing, after 10 minutes another die. No, at a time we are going to throw the 2 dice. Suppose this 2 dice I am throwing, here I will be getting 1, here I will getting 2. Maybe here I will get it 3, here I will get it 5. Like that, how many possibilities are there? Our total possibility only, our total outcome only, sample space, we know it. And we know it, if it is 1 die or 2 die, the dice to find out the total outcome, the formula it is there. It's nothing but 6 power n. Now 2 dice we have, so 6 square, it's nothing but 36 outcomes we are going to get. 36 possibilities are there. That is, here 1 means here 1, here 1 means here 2, like that 36 possibilities. Now what they are asking, find the mean and variance. Find the mean and variance. Just now we discussed also, that is the before slides, under discrete the formulas, under continuous we discussed the formulas. Solution. In throwing 2 dice at a time, it is given in the question, 2 dice at a time we are throwing. The sample space, that is the formula is 6 power n. So 6 square equal to 36. So we can see it, 36 it is written. How it is written, this sample space? Very easy way. The first die we fixed 1. You can see this is first die. Fixed. Second die we are changing. 1, 2, 3, 4, 5, 6. The first row is completed. Then second row, in the first die we fixed 2. Then 1, 2, 3, 4. This is an easy way to fill up the 36 outcomes. Second row completed. Then third row, the first die you fix 3. You can see the first one, 3, 3, 3. Second one, 1, 2, 3, 4, 5, 6. Third row also we completed. Fourth one, the first one we will fix 4, 4, 4, 4, 4. 1, 2, 3, 4, 5, 6. Fourth row completed. Similarly, fifth and sixth. So 36 possibilities satisfying this formula because we have 2 dice. 36 possibilities, sample space also very ready now. What they are asking us? Mean and variance. Mean formula we know it. Variance formula also we know it. That we have to substitute. Yeah, it is kept all the sample space to do the problem. So now, the question it is given, very clear picture it is given. Sum. First 1, 1, we will add it. We are getting 2. Keep it in our mind, 2 dice. The first data is first die what we are getting. Second is the second die, what is the number we are getting. The question is find the sum of the 2 dice if they are thrown. So the starting data is 1, 1. So it is 2. That is what it is written here too. Basic definition of probability. basic definition of probability is sum is our condition, favoring that condition or satisfying that condition. The two to get, the value to get, how many possibility it is there? Only one possibility divided by total possibility. Total possibility, it's nothing but sample space. Total possibility is 36. So when the sum is 2, the probability is 1 by 36. Clear? Next, 1, 2, adding 3. Here is that. 1, 2, adding 3. 3 it is written here. How it is written? 2 by 36. We can see it here. Here 3 is coming. Here also 3 is coming. So favoring our condition, 2 possibilities are there. That is the reason 2 by 36. Next, this adding, what we are going to get? 4. We can see it. So 4, how many possibilities are there? Here 1, here 1, here 1. So total how many possibilities? 3 possibilities. That is the reason when it is 4, the probability of 4 is 3 by 36. Next possibility is 1 and 4 adding, we are getting 5. How many possibilities? Yeah, it is 4 by 36. How? It is here 5, here also 1, 5, 2, here 1, 3, here 1, 4. That is what here? 4 by 36. Next. This both if we add, we are getting 6. 6 purpose it is written, the possibility is 5. Whether it is correct or not, here 6, here also 6, here 6, here 6, here 6. Clear? So total possibility is 5. Favoring our condition. That is only basic definition of probability. How many sample points favoring our given question condition divided by total possibilities of sample space. This is the basic definition of probability satisfying we did. The last one is 1 and 6. 1 and 6 adding, we are getting 7. So 7, we can see how many possibilities. Here it is written 6 possibilities. Let us check. 1, 2, 3, 4, 5, 6. Yeah, it is fine. Correctly we are doing. Next, leftover you can see this here. 2 and 6 is there. We are adding, we are getting 8. So 8 to get, what are the possibilities? It is there 5 by 36. Whether it is correct? Here 1, 2, 3, 4, 5. Yeah, this is also correct. Next we can see 3 and 6. What is the possibility? 9. To get the sum, the value 9, telling 4 possibilities are there. So 3, 6, 4, 5, 5, 4, 6, 3. So 4 possibilities are there. Next, 10. Here we can see it 4 and 6. What are the possibilities? 3 possibilities. 1, 2, 3. So that is what it is written. When it is 10, the possibility is 3 by 36. The next is, here the leftover is 5 and 6. If we are adding, 11 we will be getting. 11 to get possibility, easily we can tell here 1 possibility, here 1 possibility. Compulsory here what? It should come 2 possibilities. 2 by 36. Clear? Everything we completed. The last one is 6, 6. If we add, we will be getting 12. What is the possibility? 12 to get answer. The sum, SUM sum. Only 1 possibility. That is what it is, 1 by 36. So this is the distribution table. This is the probability distribution table we constructed. If we construct only, we will take this 2 as x1, this is as x2, so on we will be taking. Now probability of x1, it's nothing but 1 by 36. Probability of x2, it's nothing but 2 by 36. Each the real number, we are going to give some name, x1, x2, so on up to, according to the table. Clear? Yeah, we will see it. Mean. This is the formula, mean. Mean, this is mu, I equal to 1 to n, pi xi equal to expectation of x. I equal to 1 to 11. The meaning is, this x1, x2, x3, x4, x5, x6, 7, 8, 9, 10, 11. Each 2 we have given the name as x1. The last, the 12 name is x11. How we are having our own names? Similarly, this real numbers, we have given some names. The 2 is playing the role of x1. Continue. x2, x2 up to, according to our table, the 12, the real number, the name is x11. So formula is 1 to n is our formula. According to our problem, it is 1 to 11. It's very clear. Pi xi. Now the summation, wherever I, it is going to take the value from 1 to 11. We will substitute. We substituted. That is, I wherever, we started from 1. Yeah, I has taken the value 1. Here I has taken the value 2. 3, 4, 5, 6, 7, 8, 9, 10, 11. Why we stopped up to 11? Why we are not going to 12? Because our table is up to 11, the name giving x1, x2, x3, x4, x5, x6, x7, x8, x9, x10, x11. The last is x11. That is the reason. Here also we have taken 1 to 11. Here also we stopped up to 11. The point is clear. Now we have to, from the table, we have to pick up the values. x1, it's nothing but 2. So P of x1, it's nothing but P1. That is the formula. P of x2, it's nothing but P2. Now, this is of x1, it's nothing but 2. What about P1? P1 is nothing but 1 by 36. We can see it here. Yeah, we can see it here. x1, here 2. P1, it's nothing but 1 by 36. x2, it's nothing but 3. It is written here. P2 is 2 by 36. Similarly, x3, 4. P3 is 3 by 36. The last one we can see it. x11, it's nothing but 12. P11, it's nothing but 1 by 36. The similar way, all the values are substituted. Looking at the table, we picked the values from the table. Yeah, that is the last actually. The previous slide, the values are kept. So 1 by 36, if you are noticing, each and every term, it is there. We have taken common out. The balance, it is kept inside the bracket. So 1 by 36, if we are adding these values, we got it 252. It's nothing but 7. We got it. So now we can see it. This table, it is kept because with this table only, whatever we want, we have to pick. So it's a very clear picture about it. So now all the values we picked from this table and we got it. The final answer is 7. Variance. We found a mean. Now we will find variance. Variance formula, it is here. Yeah. I equal to 1 to 11 pi xi square minus mu square. Why it is up to 11 also we understood. According to our problem, the table up to x11. Now we are substituting in this formula where I, first we substituted 1. So p1 x1 square. Next p2 x2 square up to, so we have to see it here. So this is not there. Up to p11 x11 square minus mu square. All the values are substituted. We can see it here. Now we can see it. Here it is not that this term. So we picked, how we picked it. Here P1, this is the value. This is X1, 2. So it is 2 square. Next P2, it is 2 by 36. X2 is 3. So it is 3 square. The last one, got it? It is P11. The P11, it's nothing but 1 by 36. X11, it's nothing but 12. So it is 12 square minus mu square. Just now the previous slide we got it. Mu equal to 7. So 7 square. Okay, this term it is not there. Clear, up to 11 only our table, because easily we can x1, x2, I'll name it also, x4, x5, x6, 7, 8, 9, 10, it is 11. Clear. So this 49, how we got it, that is the mean of the discrete probabilities distribution is 7, that we substituted. Now we can do the calculations. What is the value result we are going to get? It's nothing but variance of the discrete probability distribution. So we can see it. So here throughout we are noticing the 1 by 36 is common. We have taken remaining all, we put it inside. We got the value 5.83. This addition we got it. It's 1974 minus 49. So this is the distribution table. First we have to construct. From this table only we got all these values. Entire values we got it from what we constructed from this probability distribution table. So now next we can see it. So now we discussed about a discrete. Now we will move to continuous probability distribution. We can see. Find the value of k and the distribution function capital F of x. The distribution function capital F of x means cumulative distribution. And given the probability density function, the word itself density function, it gives an indication that we are in the continuous probability distribution. So the students should in a position to identify which is a discrete, which is continuous. The probability density function which is related to our continuous probability distribution. This is the function which is given. We can see it now. Since the total probability is, first we have to find this value of k. Any value, the constant value to find, this is a very easy way to come out with the answer. The total probability is always 1. That formula if you take easily with the solution we can come out. Since the total probability is 1, this is the formula, because whether the continuous probability exists or not, two conditions are there. This is one of that condition. So in this we are going to substitute. That is minus infinity to infinity f of x dx equal to 1. We can check the question also. The question also, it is given x lies between minus infinity to infinity. This is the function. So the function, this f of x can be replaced by our given question function. So this is our question. So f of x is replaced by the function because even the interval condition also satisfied. K we have taken out. We know it. Integral dx by 1 plus x square. It's nothing but tan inverse x. That integral, the value we put it here, minus infinity to infinity, which is equal to 1. K, first x place we are substituting infinity. So it is substituted. This is a formula minus, and here the lower limit is minus infinity. That is also substituted. So k of, so here you can see it, pi by 2 minus of, this is nothing but minus pi by 2 equal to 1. So k of here minus into minus, it's nothing but plus 2 pi by 2, which is equal to 1. So k into pi equal to 1, k value we are getting 1 by pi. So using this formula, the total probability is 1. We evaluated the value k equal to 1 by pi. Now our function is this one. But the definition of the distribution function, we have to do it. This is the distribution function we will call, otherwise cumulative distribution. Any way we can call. This is the cumulative distribution function under continuous. Continuous compulsory integral will play a role. Now minus infinity to x, f of x dx. So minus infinity to x, this function is replaced here, k by x square plus 1 dx. Now k is brought it out. We know the integral dx by 1 plus x square, it's nothing but tan inverse x. That only, it is the integral, is nothing but tan inverse x minus infinity to x. Now k of, k value, the previous slide, just now we have discussed about it. The k value, what we have got it, it is substituted in the place of k. So tan inverse of x minus tan inverse of minus infinity. So 1 by pi tan inverse of x minus of, so this minus is this, tan inverse of infinity is pi by 2. So 1 by pi tan inverse x minus into minus plus. So, plus pi by 2. So now, so the previous one problem we did. One more problem we will do it. The length of time, m minutes, that a certain lady speaks on the telephone is found to be random phenomena. The lady, she is going on speaking m minutes, and with a probability function specified by the function, the probability density function. So the word itself, density function, it gives an indication to that, yes, using continuous probability distribution, we are going to solve this problem. Yeah, it is the function is given. Strictly it is told x is greater than or equal to 0. 0 is included. From 0 to where it is not given, it is understood that up to infinity. 0 to infinity, this function is there. Remaining other intervals and all, it is, the function is 0. That is given in the question. First question we have to understand, because of this probability density function, two distributions we are discussing. Discrete and continuous probability distribution. Why this problem it is not selected under discrete? Why we are moving to continuous probability? Because of this probability density function. That is given, that is the reason our memory space, it's moving, it's working, it's functioning towards continuous probability distribution. Now, the problem condition x is greater than or equal to 0. The meaning is 0 is included from 0 to where? It is not given. It is understood that it is up to infinity. It goes on. 0 to infinity, this function is this one. Remaining other, whatever the interval, the function is 0. That is the question condition first we are understanding. Then they are telling us to find out what is the value of a. If f of x is a density function. Next, they are asking, what is the probability that the number of minutes that the lady, she is speaking over the phone, is more than 10 minutes. So, this condition is telling, and they themselves, they told it is a density function. Find the value of a, first question, more than 10 minutes. So, greater than 10, what is the probability? So, the two conditions we have to deal now. And we selected also continuous probability distribution. This problem related. We can see it now. Yeah, since the total probability is always unity. Yeah, this is because continuous. The problem comes under the given problem at present. What we are dealing, it is continuous probability distribution. Continuous probability distribution, this is the formula that is written. Now, minus infinity to 0, 0 to infinity f of x. Now, so we can see this is the condition it is given. Yeah, x is greater than or equal to 0, it is given. The meaning is 0 to infinity only, it exist, the function exists, but our formula is minus infinity to infinity. So this 0 should be inserted in the formula. We inserted it. Minus infinity to 0, 0 to infinity. Whether inserted correct or not? Yeah, we checked it. It is correct. So the balance, the previous step we have to get it. The previous step we got it. Minus infinity to infinity. Now first integral exist or not? No, it doesn't exist. Strictly it is told x lies between 0 to infinity only. The function it is there. Remaining other intervals and all it is 0. So the first integral is 0. The second one, we substituted the given function. And second one, this a we have taken out. The balance it is kept, and a of the integral it is done. So e power minus x by 5. This integral we want it. E of some term is there. What is the integral? E of the sum term, you write it as it is. We will write it as it is. Divided by, regarding which we are doing the integration. We are doing integration with respect to x we are doing. So the coefficient of x, very simple thing. Coefficient of x, x will leave. The balance is minus 1 by 5. That we have to put it down. Very simple way. E power minus x by 5 dx. E power some term, same as it is will come for the integration of exponential terms, divided by, regarding with we are doing the integration, with respect to x we are doing. So x, the coefficient of x, the meaning is leave that x, balance is minus 1 by 5. That should be divided by. That is the thing, integration. We have to do it for exponential. It is written same that only. 0 to infinity. e power minus infinity, the value is always 0. You can see the function it is kept here. So we did clearly. You can see it. So minus 5a, the last step it is written here. Minus 5a, e power minus infinity, the value which is equal to 0. So minus 5a. So first we are substituting the infinity, we are substituting. So e power minus infinity, that is a 0. This is formula minus upper limit minus lower limit. E power 0 value is, we know it, 1. Because according to exponential law, a power 0 always 1. Using that exponential law, here e power 0 equal to 1. So minus 5a, here minus is there, minus minus plus. So 5a equal to 1, a equal to 1 by 5. So the first question, we solved it. So that lady, she speaks over the phone. We want it if it is greater than 10 minutes. What is the probability? So 10 to infinity we kept. A, it has been taken out. 10 to infinity, e power minus x by 5 dx. Simple integration, we know it very well now. E power minus x by 5, e power exponential of some term. So exponential same some term will come, divided by x coefficient. Leave x. The balance is 1 by 5. The integration is completed. So we can see it here. Yeah, that's what here the integration is there. 1 by 5. That is what is the a value we got it. We substituted it. 1 by 5. This minus 1 by 5 we brought in up. It has become minus 5. That is something minus 1 by 5 is there. We are bringing to up. It is becoming minus 5. Then the balance it is written as it is here. 5 getting cancelled. Balance is minus. E power minus infinity value we know it 0. So the upper value x place we are substituting because we did integration with respect to x. So minus upper one is what? 0. Here what? Minus. The down is what? 10. So x place we have to put it 10. So minus 10 by 5. It's nothing but e power minus 2. Here minus is there. Out also one minus is there. It is becoming e power minus 2. It's nothing but 1 by e square. So we will come to the conclusion. Today what we discussed in this lecture. Discrete probability distribution or probability mass function. We discussed it. And properties of probability density function. Otherwise, we'll call it as continuous distribution. And we have taken a particular one problem we have taken. So one problem, the sum of that is 2 coins we have taken. Two dice are thrown and we found mean and variance. And this function we have taken and we determined the value of k and distribution function, that is cumulative distribution function, we got it. And one more problem we did, f of x equal to a e power minus x by 5. Strictly 0 to infinity means this function exists, and to find the value of whatever the constants, we used the total probability distribution formula, we used it. Here, this is the thing. And the telephone, continuously, the phone calls are coming. We particularly greater than 10 minutes means what is the probability? That is also we discussed. Mainly we focused in this lecture, the difference. The problems comes under, whether it comes under discrete or continuous. That we mainly focused on it. So we can see it. This is through. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.